Okay, class, today we are going to graph sine and cosine functions. So here we have the four parent functions. So it's really just sine and cosine are the two parent functions, but I'm illustrating when we have a negative in front of the sine, the parent function gets reflected across the x-axis. So for example, if I take my sine and I reflect my points across the x-axis, and I were to connect the dots, this, what I have in red, is actually the negative sine function, which I have down here. See it going down and then back up again. And when we did graphing in Algebra 2, we did see that when there was a negative value out front, it was a reflection across the x-axis. Okay, so we have cosine. So cosine starts at its max and go down. If we reflect it across its x-axis, would start at its min, go up to its max, back down again, which we see is with the negative cosine function. So those are the base graph, the sine and cosine with the negatives as well, the reflection across the x-axis. So what we're going to do is we're going to talk about the rules and the different attributes when we stretch it and shrink it and do some shifts. So some general rules is we are going to use graph paper and a ruler, and we're going to label the key points, and the key points were the 5 that I showed you that made up each graph, and we're going to label those on the axes, and then after we graph those, and we're going to shift and translate accordingly, and we're always going to connect with a smooth curve, and it shouldn't be pointy. And in your textbook, when it says sketch, it means graph and use your key points. So we're going to graph these two key base graphs with all of the shifts. We're going to graph the sine and the cosine, and we're going to talk about A, where the amplitude of A is the absolute value of A would be the amplitude or the vertical stretch of the graph. B is going to reflect the period. In fact, the formula for the change in period is 2 pi r b, and the period talks about the speed of the graph, which we will investigate more. C is going to be the horizontal shift, and in fact the horizontal shift factor is C over B, and then D is the vertical shift. Okay, so let's get graphing. So here we're going to graph y equals 2 sine x. So we know that the general base function for the sine function was that it looked like that with these key points. Right, you had your midline. Right, this was the x-axis, and started at the origin, went up, back to the midline, to its min, and back to the midline. Okay, so we're going to graph 2 periods of it, but our amplitude, our A value, is 2, so our amplitude is the absolute value of that, which is 2. So it starts at the origin, and at the next key point, it is going to go up to 2, because the amplitude was 2, and at the next key point, and then it's going to go back down, and then it's going to go back up again. So it keeps the same general shape, but instead of it originally having amplitude of 1 and going down to -1, it goes up to 2 and goes up to down to -2. So it has this vertical stretch. And if we start on the right hand side and continue with the pattern, we would go down to -2, back up, and up to its maximum and back down. And then we're going to connect it with a smooth curve. And then we have arrows on both ends. And I want to see that both arrows, one goes up and one goes down, and I'm looking for all of my key points. Okay, and the key points are always evenly spaced along the x-axis. Okay, so in my particular example, I'm using every other box just to kind of spread it out. For me, sometimes if I do every box, it can get a little cramped, but you can do every box, but each one should be evenly spaced. Okay, so originally the period was 2 pi. That was the distance for one of those curves is 2 pi. And we're always going to have those 5 key points. So if I split it evenly, halfway to 2 pi is pi. If I go halfway to pi, that's pi over 2. So each key point would be 1 pi over 2 pi, 3 pi over 2, 2 pi, and then backwards. So this function is going to continue going in this up and down motion for all, and it would be all real numbers, which we can denote -infinity to infinity. And we also have this notation, this upside down A for all, and then this R for all real numbers. You can use either notations. The range, it's only between -2 and 2, and it includes a min of -2, and it includes a 2. So in inequality notation, we would say between -2 and 2. Including those values. And our book uses for less than or equal to this square bracket with a -2, and then a comma, and then a square, then the 2, and then another square bracket. So from -2 to 2. That would be similar to this notation. In inequality notation, we would write it as x is bigger than negative infinity and less than infinity. So the numbers go in the same order. If it's strictly less than, it's a round bracket. If it's less than or equal to, the or equal to gives it a square bracket. So now we're going to find the x-intercept. So I'm going to start in the middle. It's at 0. The next x-intercept is pi and 2 pi. Notice they're all multiples of pi. I'm going to go in the back, minus pi minus 2 pi. And since it does go on forever, I'm going to denote it with that, indicating it goes in both directions. And we will investigate a new notation for that as well. The y-intercept, there's only one, and it's at the origin, 0, 0. Okay, let's move on to the next problem. Here we're going to graph 2 periods of y equals -3 cosine of x. So remember, cosine started out as max, but negative cosine starts at the min, and this is downward u function. And here's the midline, the x-axis, and then it's maximum. Okay, and since its amplitude is the absolute value of a, that's the absolute value of -3, which is 3, which means its max is going to be 3 and its min is going to be 3. So it's going to go up to 3 and down to -3. And it starts, this was our y-axis and our x-axis, it starts at its minimum, which is going to be -3. And then, remember, the period was 2 pi, so at each of the key points, it's going to go up and then up again to +3, because the amplitude was 3, and then back to the midline, and finally, so we have this downward shape u, and since it's really stretched, sometimes it's hard to make it look curved. And then down here, remember, this is the min at 2 pi, so we want it to go back up again. On the the left-hand side, we're going to go up. And remember, all of our points have to be evenly spaced. And we're going to do one more period on the left side of the x-axis. Now, I've set up the graph paper to do one period over here on the positive x-axis and one period here on the negative x-axis. It, of course, would be correct to do one period in the positive x-axis and then another period after that, so that you would have 2 periods to the right of the y-axis. That would be okay too. The domain is, again, all real numbers, so you can denote it all real numbers, or you can say x is bigger than -infinity and less than infinity, or so this is inequality notation, that notation, or we can say it's -infinity to infinity in interval notation. Our book uses this interval notation, so I wanted to bring it up. The y values go between -3 and 3, -3 and 3, and it includes -3 and 3, so we are going to have these square brackets. Or you can say y is less than or equal to 3 and bigger than or equal to -3. The x-intercept is at pi over 2 and 3 pi over 2, and it's going to continue going in that pattern, and then again at -pi over 2 and -3 pi over 2. So remember, the original function, when it has cosine of x, it's going to have a period of 2 pi, which means it's going to have one entire u shape in the distance of 2 pi. And if I need to find these key points, I know halfway would be at pi, and halfway there would be at pi over 2. So I would have 1 pi over 2, pi, 3 pi over 2, and so on. The y-intercept was at minimum is at -3, so the y-intercept is -3, so it's at 0, -3. Okay, so here we're going to graph these two functions. We're going to investigate what it looks like with the 2 or 1/2 in front. So really what it is a difference in amplitudes. So for the first cosine function, your amplitude, your a value is 2, and the second one, our a value, is 1/2. And I'm going to go ahead and graph the two of them, one in purple and one of them red, so we can distinguish. So the general shape for the cosine function is that it starts at its max and goes back down. So one period is going to have these. I'm going to graph 2 periods for each of them. So I'm going to do 2 of those u's. So it's going to span from 0 to 2 pi. So each of my key points will be evenly spaced. So it's going to be here. And as long as we don't have a change in period, these are going to be the key values on the x-axis. So it starts at its max, which is at 2. And it's going to go down to its min, or middle, and then min, back to the middle, then to the max. So this is 1 period of my first function for cosine. Now I want to make sure I see this as a max with the arrow going down again. And I'm going to continue this pattern going in the other direction and have my other u. You want to make sure it looks like a U shape and not V shape, and you do want to connect your dots. Okay, so now I've connected. I have arrows on both ends, and all of my key points are labeled. So that's with the amplitude of 2. So now let's do it with the amplitude of 1/2. So it's going to look the same, but instead it's going to go up to 1/2 and just down to minus 1/2. So it starts at its max, goes to the midline, then to the min, then the midline, and then the max. So search its max, goes to the midline, the min, midline, max. Oops, I was off by 1. This point should be all the way over there. That's where the max is, because I'm doing it every other box. And down again. So I go 2 spaces over, it reaches its midline, 2 spaces over, reaches its min, 2 spaces over the midline, 2 spaces over, reaches its max. It's just going to continue in this pattern. Okay, so I have 2 U shapes. I have arrows on both ends. The difference between the two is the purple one gets stretched up to 2, and the red one gets squashed up down to 1/2. Remember, the base function had an amplitude of 1, so the wave went between 1 and minus 1. Okay, so that is about changes in amplitude.